Einstein once looked at the most successful theory in the history of science and said something almost nobody expected. He said it was wrong. Not wrong like the math was broken, wrong like something was missing, hiding underneath it. And he spent the last 30 years of his life trying to prove it. Today, you're going to find out what he thought was hiding there, and what happened when Richard Feynman, decades later, looked at the exact same crack in reality and figured out what was actually behind it. Stick around, because the answer is not what you think. And by the end of this, you're going to look at literally everything around you a little differently. Let's set the scene. It's 1935. Quantum mechanics is barely 30 years old, and it's already rewriting the rules of the universe. Electrons acting like waves. Particles that don't have a definite position until you measure them. Cats that are supposedly alive and dead at the same time in a box. Wild stuff. Most of the physics world is on board, but Einstein isn't buying all of it. Not because he doesn't understand the math. He basically helped build parts of it. He's not buying it because something about it feels incomplete, like reading the last chapter of a book and realizing 3 pages got ripped out. So Einstein, along with 2 other physicists, Boris Podolsky and Nathan Rosen, writes a paper. It becomes known as the EPR paper, 1 letter for each of their last names. And this paper is basically a trap. A really elegant, really clever trap built entirely out of logic. Here's the setup. In quantum mechanics, 2 particles can become linked in a strange way. Physicists call it entanglement. Once 2 particles are entangled, measuring one of them instantly tells you something about the other one, even if that other particle is a mile away, or 1,000 miles away, or on the other side of the galaxy. Measure one, and you instantly know the state of its twin. Now here's where Einstein's brain goes to work. He says, wait a second. For that instant connection to make sense, one of 2 things has to be true. Either some kind of signal is flying between the particles faster than light, which breaks everything we know about the universe. Or, and this is the part he actually believed, the particles already had those properties the whole time. They weren't undefined and floating in possibility. They were secretly carrying hidden information from the very start, like 2 sealed envelopes that already had the answer written inside before anyone opened them. Einstein liked that second option a lot more, because option 1 breaks relativity, his own life's work. Option 2 just means quantum mechanics is incomplete. It means there's some deeper layer of reality, some hidden variables we haven't discovered yet, and once we do, the universe will make sense again in a nice, orderly, predictable way. This is where his famous line comes from. God does not play dice with the universe. He wasn't rejecting quantum mechanics as useless. He was rejecting the idea that reality is fundamentally random at its core. He wanted there to be an answer underneath the uncertainty. And for decades, this was basically a philosophical standoff. Bohr, the other big name in this story, argued back that there's no hidden layer, that particles genuinely don't have definite properties until they're measured. And that's just how nature works, whether we like it or not. 2 brilliant men staring at the same equations, coming to completely opposite conclusions about what reality actually is underneath. And for a long time, nobody could prove either of them right, because it looked like philosophy, not physics. You couldn't test it, or so everyone thought. This is usually where the story stalls out, in most explanations you've seen online. Einstein said one thing, Bohr said another. Cut to black. Roll credits. Mystery unsolved. But that is not where this story ends. Because decades later, people started asking a very different question. Not who's right philosophically, but is there an experiment that could actually settle this? That work started with a physicist named John Bell, who figured out a clever mathematical way to test whether hidden variables could really be behind entanglement. But the person who took that whole idea and made it click for regular people, who explained what was really going on underneath all of this in a way that made physicists rethink how they even talked about quantum weirdness, was Richard Feynman. Feynman had this incredible gift. He didn't just do the math. He hunted down what the math was actually saying about reality, and he wasn't afraid to say the uncomfortable part out loud. And the uncomfortable part is this. Feynman basically said, look, I can tell you how to calculate everything in quantum mechanics perfectly. Every experiment matches the prediction. But if you're asking me to explain why it's happening in a way that feels intuitive, in a way that matches your everyday experience of reality, I can't do that, and neither can anyone else, because that's not how nature is built underneath. So here's the twist, the thing Einstein thought quantum mechanics was hiding, that secret extra layer, those hidden variables, that neat explanation waiting to be discovered. It wasn't hiding a deeper, more comfortable version of reality. It was hiding the fact that reality itself doesn't work the way our brains want it to. When physicists actually ran the experiments Bell designed, over and over again, with better and better technology, the results kept lining up with quantum mechanics and not with Einstein's hidden variable idea. Entangled particles really do behave as if their properties aren't fixed until measurement happens. There's no secret envelope with the answer already written inside. Reality genuinely seems to be undecided until the moment you look. Now stop for a second, because I want you to actually sit with what that means, because most people scroll right past this part. This isn't saying we don't know the answer yet, because our tools aren't good enough. This is saying that the universe, at its most basic level, might not have a definite answer until something interacts with it, not hidden, not secret, genuinely undetermined. That's the part that used to bother Einstein so much. Not that quantum mechanics gave wrong predictions, because it never did. What bothered him was the idea that the universe could be fundamentally probabilistic at its core, with no hidden order underneath holding it all together like a safety net. And here's where Feynman's perspective flips the whole thing on its head in a way that I think is honestly kind of beautiful. Feynman wasn't devastated by this the way Einstein was. He basically said, fine, if nature is weird, let's stop trying to force it into the box of human intuition and just describe it accurately on its own terms. He used to say that if you think you understand quantum mechanics, you don't understand quantum mechanics. And he meant it as a compliment to the universe, not an insult to your intelligence. It's not that you're too dumb to get it. It's that nature never agreed to make sense to a brain that evolved to dodge lines and find fruit on the savannah. So, what was actually hiding underneath Einstein's flaw? Not a tidy hidden mechanism, not a secret set of instructions. What was hiding was the real, tested, experimentally confirmed fact that the universe doesn't wait around to have properties until something forces it to decide. Particles a galaxy apart can be correlated in ways that have no classical explanation, and no faster than light signal is required, because nothing is actually being sent. The connection was built in from the moment the particles became entangled, not communicated afterward. Here's the part that should genuinely mess with your head for a second. This isn't some fringe theory. This is confirmed, tested, repeated in labs around the world. And in 2022, 3 physicists won the Nobel Prize, specifically for experiments proving entanglement is real, and hidden variables like Einstein imagined don't hold up. Einstein's gut instinct, the thing he was so sure had to be true, turned out to be the one part of this whole saga that didn't survive contact with reality. And somehow, that's not a sad ending. It's one of the most fascinating plot twists in the history of science, because it means the universe is stranger and more interesting than even Einstein was willing to accept. Think about what this means every single time you look at anything solid around you right now. Your phone, your desk, the walls of the room you're sitting in. All of it is built from particles that, at the smallest scale, don't behave like tiny solid billiard balls with fixed properties waiting to be discovered. They behave like possibilities that only settle into something definite the moment they're observed or measured or interacted with. Reality has this strange, unfinished quality at the bottom of everything, and it's been sitting there this whole time, whether or not we were paying attention. That's the flaw Einstein saw, and that's what it was actually hiding. Not a comforting answer, something stranger, and honestly something a lot more interesting than the one he was hoping for. If this kind of thing fries your brain in the best way, that means you're exactly the kind of person this channel is for. Hit subscribe so you don't miss the next one. Drop a like if this actually changed how you think about reality even a little bit. And let me know in the comments, if particles don't have definite properties until they're measured, what does that actually mean for something like you, made of trillions of those same undecided particles? I'll see you in the next one.